for this 3D project, one of my sons approached me. He's rebuilding a 87 Firebird, Pontiac Firebird, and one of the issues he came up with when he was able to drive the vehicle was the odometer wasn't working. So he took the odometer apart, and the brown gear I'm showing here is broken. And so what we needed to do is create a new one, like the white one I've got, and then put that in the odometer, install everything back in the vehicle, and then test it out. We were able to create the gear, but we're not able to test it out because we don't have the engine in the car right now. So unless we're going to go push the car down the street and see if the odometer's working, we don't know. But the gear itself, it's two gears in one. The bottom is a helical that goes into a worm gear, and then the top is just a straight. I already have FreeCad opened, and I've created a spreadsheet in FreeCad to handle all of my variables. The helic part of the gear, I needed to go to a 7, whatever the value for 7 is, but it kept pushing it back up to 8. So I think the add-on only goes to 8 and won't go any lower than that. And then the height of different modules, or the parts, diameters, I've got that all in a spreadsheet so that I can just reference these to create my gear. The gear itself, in the drop downs, I have this gear added in here. To add in, that's an add-in. You go to Tools, Add-in Manager, and then scroll down till you see FreeCAD Gears, which I already have installed, and you'll see this gear add-in, which gives you a number of different types of gears, of which I'm only interested in one, to be able to bring into your FreeCAD. So I'm just closing this because it's already there. So what we're going to do is go up and start with a gear, and this particular gear, the tab on it comes up and says create an external involutive gear. That's the one I'm going to use, so we're going to create that. And so that created this gear right here. If I can figure out how to. So this will be the bottom gear, and you notice I have not created a body in the FreeCAD yet. I came up with an issue with FreeCAD where having two parts in one body created a problem when I was trying to do a hole. It's probably, I don't know how to use the product, but that's a different issue. Okay, so now for the gear, we're going to put this, the height, click on it, click the little circle. We'll do the spreadsheet, and this will be bottom height, and it sets the height to 4.9. Then we're going to set the module. The number of teeth is 15. That just happened to work out. The module is another spreadsheet value. Bottom module is 0.065, which brings the diameter of the part down to where I want it. And now we've got, these are straight gears. I need to make this into a helic. So this is where we'll put in the value of 8. Helic beta, which I'd rather have it as 7, but it kept changing it. So now we have the helix on the gear. Just a little bit of a helix to mesh up with that worm gear that I need. So now that that gear is created, we're going to come back and do a part design, which does start part and create body. So now we have a body in the gear, and the first gear is outside of that body at this point. We're going to go back to the gears and we're going to create another gear. This gear, we need to change the Z placement to the height of the bottom part. So that moves the gear up. Then we're going to change the height. Both gears ended up being the same height. To 4.9. The number of teeth needed to be 11, which is in the spreadsheet. Oops, I want top teeth. And then we need to do the module. So now we have two gears, one on top of each other, and we need to put a hole through the center of this. So the first thing I need to do is get a copy of this first gear into the body. Not knowing how FreeCAD works, this grayed out, so my assumption is it's now in the body as the base feature. So what we do at this point is we create a sketch on the top, create sketch on the flat face, and then we're going to put a circle and then we're going to put a constraint on that circle. And that constraint will be in the spreadsheet, which is hole radius. So now we have the radius of 1.75. And we see we're fully constrained on the object. I'm not sure where my object went here, but we need to bring the sketch back into the part. We're going to select that circle and we're going to do a part design. I'm going to do a hole. That hole is going to be in a spreadsheet, hole diameter. So there is my dimension. This should go all the way through, and it is. See, parts in FreeCAD just kind of magically disappear and then come back. So now this is the part with the hole all the way through, helical offset on the gear for the bottom gear, and straight gear for the top for meshing in. So now what we'll do, we'll select the body, we'll do save, which saves it as gear 5 for me, and then we're going to do an export. I already have it saved as a different, so we're going to save it again as a still file, STL, for bringing it into Cura for 3D printing. So now I've got Cura opened. What we want to do is bring in that file we exported from FreeCAD as a still STL file into Cura so that we can make the G-code file. So here's the file. Little tiny thing. This is maybe a centimeter by a centimeter. But here you can see it's got the hole through it. There's my part. So once this is in Cura, we would come in and do 100% infill. And yeah, I may or may not print this on a raft. Right now it's just on the skirt. So if I do a slice with this, to print it with the skirt will be 9 minutes, depending on the how level your bed is as to whether this will work for you or not. And if you came back and printed this with a raft, we'll do a slice. This will be probably about 11 minutes. And so that would give you a little raft with the hole through the center. So then you'll save this to save it to the disk as gear 5. And now you're ready to send that over to your 3D printer and print it. Here's where it went in pictures here. Kind of hard to show, but and then here's with the actual gear in place, spinning it by hand, and demonstrating how it would actually work in the odometer. So in this particular case, we were able to guess relatively close enough, and the worm gear meshed up with the helical gear, the other gear messed up with the odometer gears, and hopefully when we get this back in the vehicle and the motor in and everything else, we'll know if the odometer is working.